Good evening guys, on this video, I will be presenting a software simulation using RAM connection standalone. So let's get into it. Once it opens, the software greets you with a dialog box containing updates, tutorials, and options in case you want to change the feed channel filters. So we're gonna close this one up and proceed on the important and commonly used buttons on the software's ribbon. In the Home tab, we can see joints, load conditions, and databases. In the joint group, we have the new button. This is where you can start creating joints and adding specific loads. Let's see what's inside this button. So what we have here is a dialog box containing two tabs. First is the joint data. We can see here the properties and values to consider. The properties shown may vary with what joint you select. For example, I'll choose beam to column flange, and it shows a different set of properties. But for the example later, I will be using beam to girder. On the first three rows, we have the joint. As I have mentioned, it has these options such as BCF or beam to column flange, BCW or beam to column web, BG or beam to girder, and etc. Below joint is the description, in case you'll want to name the joint to easily identify them later on. And also, if your connection does not have or it does have an opposite beam, you can check this one out. For the beam properties, this is where you can select what kind of section you'd want to use. Below is where you can choose what kind of material for the steel and steel anchor rods. We also have the skew and slope angle. Skew angle is the horizontal angle in degrees between members that do not meet at right angles in the horizontal plane, while slope angle is the vertical angle between the support axis and the longitudinal axis of the beam in degrees. There are also beam setback and member length. It has this cool feature wherein it converts the units in real time. For example, I will input 1 cm on this box that has an inches unit, and it automatically does the job for you. And the last one for the beam, we have this property called continuous lateral torsional restraint. This is used when the beam has a restraint. And lastly, for the girder properties, we can also define its section and material on this side. On the load tab, this is where users can input the shearing and actual loads for the connection to carry, and some moments as well. Conditions may vary depending on what the user defines on the add and edit window. Going back to the Home tab, beside the new button, there are 3 sub-buttons. These are edit, delete, and delete all, and the rest are just copy and go to. Go to is used to navigate a particular joint if you have multiple joint designs. Moving on to the other group, which is load condition, we have here the add and edit button and its 2 sub-buttons, delete and generate. This is where users can define, generate, and delete load cases and combinations. And on the third or last group, we have the databases. It contains a section database, wherein you can edit sections from different countries or create your own section by adding a new group and a new section. On the material database, it is where you edit or define a material if it's not included on the list. Then for the connection database, users can see here the extended list of connections. For the bolt sizes, you can find the list on this one, and again, if you can't find your choice of size, you can always define it here. For the type of welding electrodes, there are 7 types of welding electrodes here, ranging from 60 KSI to 120 KSI. And then the last from the list, the anchor database. Steel anchors are used to connect structural and non-structural elements to concrete, and these are the sizes. So without further ado, let's start making a steel connection. The first step in the process is to create our own steel section, and to do that, let's open the section database. Create a new group and put the name of your choice. So let's just name it as Build Up Sections. After creating a new group, the next step is to add new table. You can find it below the Add New Group button. So in our beam to girder connection, we will be using wide flanges. Next is we have to identify the section by clicking this 3-dotted button. So these are the available section types in RAM connection. You can see them in 3 different views: shape view, Details View, and Section View. The white flange is located at the 5th column. Select it and click OK. In the white flange table, we will now add our own section by simply clicking the New Item button. So we will set the unit system. Let's set it to metric. And for the name of the section, we will use a 400 mm by 200 mm wide flange with 6 mm thickness for both flange and web. Always remember to put space between the symbol W and the numbers. Now we will input the dimensions. Don't worry about the units, since as I have mentioned a while ago, it will be converted automatically. And for the fillet size or distance, we will set it to 0 for now, since we are just using a theoretical section, assuming that there are no curves on the connection of flange and web. For the design restraint, we will not select neither of these two. We will note later that beams have a continuous lateral torsional restraint on the new joint window. In case you want to see the complete properties of the section you just made, you can check them out here. So these are the section information. After adding the beam section, let's also add another section to be used as the girder. Next step is to go to Add and Edit, and we will edit the load conditions. On the cases, we will only use dead load and live load for a simpler data output. And on the combinations, we will use the 1.2 dead load plus 1.6 live load. Let's name it LFRD and assign it as design type. And then click OK. You can also use Janneleih to use load combinations from different codes available. Now we move on to the new button. We will now input our beam and girder. In the joint, select beam to girder connection. Leave this blank since we will only create one connection. And also, let's assume that there is no opposite beam. On the beam property, we will use a 400 by 200 mm wide flange and a A36 material. And for the skew and slope angle, leave it to 0 since the beam and girder is connected perpendicularly. The beam setback will be at least 1 cm, and for its length, let's say 5 meters. For the continuous lateral torsional restraint, let's choose yes. And lastly, for the girder, we will use a 600 by 250 mm wide flange and again A36 material. Now let's add the loads. So again, we will use random loads or whatever we could think of since this is just an example. But if you have an ongoing structural design on STAAD, you can use the load data from it. Let's input 8.5 and maybe 7 for the shearing, and 5 should be good for both the actual loads. Note that the unit used here is in kips or 1,000 pounds. Then press OK. This is now the 3D view of the beam and girder without the connection yet. To zoom in, use mouse scroll. And for the 360 view, hold right click and hover the mouse. Next thing that we are going to do is to go to the Design tab. There's nothing much to click here. only the assign button, and we will choose from either basic or smart connection. I'm not gonna use gusset and base plate connection since we are connecting beam to girders. The difference between these two connections is that when you use basic connection, the program searches through a list of predefined connection templates and selects the first connection in the list, while for the smart connection, the software or program optimizes the connection parameter. For this example, we will use the smart connection single plate. And now, this is how the connection looks like using a single plate. For further details about the connection, simply point your cursor on the connection and then double-click. The program opens a new window called the connection pad. On the left side, you can see the general information, and below are the members and single plate info. And focusing on this part of the window, it has two tabs. This area is the 3D and this one is for the DFX or the drawing interchange format. On the 3D window tab, we have the Save and Results button. We can also see the 3D connection in 3 types of draw options. The Optimize button is also up here. Since we chose the Smart connection a while ago, the software or program already optimized the connection parameter. We can also see this green square with a value of 0.62 on the center. This is the capacity and demand ratio, or the safety factor. It is less than 1 and green in color, which means the design is safe. To see the report output, click Results. We can see that in the geometric consideration, everything is stable. And also in the design check, the most critical is the bolt bearing under shear load. But nonetheless, all the ratios are less than 1, which is good. That's pretty much it, and thank you for listening.